last class. Actually, I wrote it in the last class also, but most of you were not there because it was overtime. So today we'll try to finish the class in the two, just with one break. And hopefully you see the summary diagram of the neutron nucleus. So the first is, you remember that this is the elastic scattering. Same neutron is coming out with the different energy. Okay, and this doesn't need compound nucleus formation. And there is another elastic scattering with the compound nucleus formation. This is the compound neutron comes, neutron right, n plus x a n or x equal to a. This is whatever way you convenient. Actually, we started with n plus a. So B, C, D is the convenient way. So this is compound nucleus, and then we have a resonance elastic scattering, which is the same mass number, same Z number. Okay, and then we have here a compound nucleus in elastic scattering. This is compound nucleus. This is the same compound nucleus. This is in the excited state in the elastic scattering, and this is radiative capture. The neutron comes and we get gamma radiation. And this is a charged particle. The proton, the outgoing particle is the proton, in this case neutron, and in this case alpha particle. This is very important that there can be other charged particle reactions also, but these three usually are common. And then we have fission. So how many reactions we have? Elastic scattering, inelastic scattering, 2, number 3, radiative capture, charged particle 4, charged particle reaction, and then fission. In fission we have two, mainly measure is to actually a number of particles. Fission particles. We will talk about the fission products and fission fragments. Actually, these are the fission fragments, 2 large fission, and then we have lots of fission products, hundreds, and then 2 or 3. Okay, and we talked about the neutron producing reactions. What are the neutron producing reactions? This one is N2N on N3N. Okay, that is 2 neutrons or 3 neutrons going out, and then we have the gamma radiation, that is the neutrons that coming out with the charged particles. You see, you remember that you remember this neutron sources? These are the neutron sources that are used in the nuclear reactor. Start with. Okay, so what is this? Alpha n and gamma n. Alpha n is what? So you have an alpha particle, and the neutron will be coming out. Okay, alpha particle. So you must have alpha particle to interact with the neutrons. So what you shall have to have? So you shall have to have an alpha source, right? You remember that what we use for the alpha source? What are the sources that we use for the alpha source? You need the alpha source, right? Here you need the alpha source for this reaction. You need the alpha source. And what is the reaction? We call it beryllium, radium-beryllium source is usually used, or it can be radium plutonium, or it can be other radium polonium. Each has advantages and disadvantages. I talked about it, but today I'm not going to repeat it. Usually this reaction, then this is beryllium 9 plus gamma. We are using these reactions are due to gamma, and gamma is coming, gamma, and we get beryllium 8. Okay, and because beryllium is loosely bound, that's why just a gamma is coming. and neutron is going. Now gamma incoming particle, neutron outgoing particle in beryllium line. Okay, or it can be a neutron,
Column group. See.
gamma, and okay. So you can usually break the hydrogen, and this is a very good source. The this source can be about 10 to the power 10 to the power 7, and this can be 10 to the power 6. And we have another neutron source. Well, it's not any reaction. It's spontaneously coming neutron source, californium 252, californium 252. And as I said, that it resembles the spectrum of the fission. And sometimes we use it in the experiment in the nuclear. Most of the neutron sources in the laboratory is californium 252. Well, that's it. In fact, we will talk. We are supposed to talk with cross sections today. So before I will just introduce the cross section, and the cross section really we will start from the next class. And to start with the cross sections, you see so all these reactions, and all the materials in the reactor, the components, that is the elements of how many elements are there. So all these reactions with the neutrons is we shall have to study, we shall have to relate it some with some parameters. And the most used parameters and the most useful and the most important parameter is cross section. To relate these cross sections, to relate these reactions with the, can you imagine how many elements are in the reaction? You think of the reactor core, and then coolant, and then clad, and then the thermal sheet, and then the reactor pressure vessel, and then the shielding and air gaps, and etc. etc. So how many elements are there? Okay, and when fission takes place, how many hundreds of particles, hundreds of elements are created. So you shall have to know all these interactions with all those elements, with all these component elements in the reactor. So can you imagine how huge and how big this number is? It's very big, really very big. So, well, I'm sure that by now you have written this, and we have these reactions, and these are the neutron producing reactions. And I gave you some more details about the neutron producing reactions. Hopefully, I will be able to share with you the IAEA. Actually, for these lectures, I need the IAEA lectures so much, but unfortunately, we could not make it available. Hopefully, after the Eid, if inshallah, this COVID situation improves, you can get a copy of this from the department. Well, anyway, so we next move. So as I said, that to relate these sort of reactions with the reactor components, with the materials, whatever they are in the reactor, we shall have to have some parameters, some parametric studies. And the most important parameter is cross-section. And we will talk about cross-section. Actually, the cross-section, there is a misleading in this country, our country. The cross-section, the subject is called nuclear data. This itself is a subject. And this is the basic foundation of reactor physics. Actually, most of even the reactor physicists don't understand that how many efforts are given, how many people, hundreds of people around the world are working on this nuclear data. Nuclear data itself is a subject, and a huge number of elements, compositions, data are related with this, and experiments, theoretical models, blah, 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 lots of things are doing. As I said, that hundreds of people, it's a billions and billions dollars of industry. So lots of people, more people are working for nuclear data than people that work for reactor design and reactor other stuffs, because this is the basic foundation. The fusion reactor, all the Princeton experiment were waiting for basic nuclear data. We will talk about it because they could not analyze the experiments. So what you need is this nuclear data business. The nuclear data, as I said, we have a misleading in this country. I was the IAEA, there is a nuclear data section in IAEA, nuclear data section at IAEA. IAEA, you can go to it, IAEA. No, no. IAEA at IAEA.org. Nuclear data. Or you can just go at IAEA.org, www, where IAEA.org, and there you will find a nuclear data section. Actually, they are responsible for disseminating this nuclear data, the basic nuclear data. We'll talk about what is basic nuclear data to the third world countries and our country, you know. And there is NNDC, this is in the United States, and Oak Ridge National Laboratory. They distribute this data in the United States. And Japan has a center called Nuclear Data Center at JAIRI. They produce and they distribute data in Japan. And China has their own, it's called Sandal. China, they produce data and they distribute it. So we'll talk about it. And the European, there is a NEA data bank, NEA data bank. So I was responsible, the responsible officer for about 30 or more years actually, for as a liaison officer. So whoever from Bangladesh, you will ask for a code or any data or cross-section library, they used to, or they had to go through me, and then I send a request and they will send it to me, and then I distribute it to. Also, there were not many people who are using professional data in Bangladesh except Atomic Energy Commission, and some from Russia University and some from Dhaka University. So not many others, using nuclear data or the cross-section libraries in professional level. Okay, what I said in the professional level. But anyway, still if you go to IAEA.org, then you'll find nuclear data section, and there you can ask for computer codes and also the basic nuclear data. They will give you the basic nuclear data. I will talk about what is basic. You cannot do anything with the basic nuclear data until you customize this. And that's why comes the nuclear, data processing. And that's why it's a big industry. If you have all the neutronic codes, neutronics means that, the parameters for the neutron interactions and all these, what we get. If you learn computer codes, supercomputer codes to do this, if you have all the neutronic codes in the world and all the basic files as I was talking about, you can do nothing. You shall have to customize it. And to customize it, as I said, this itself is a subject, and there is no much talking about it in Bangladesh. So to customize it, you shall have to go through something like 20, 25 computer codes. So that's why it was a very advanced technology, and it was not available in Bangladesh. But anyway, we were able to start it in our Saval laboratory. Now we can customize our own cross-sections libraries. Anyway, so this is the background story that I'm talking you. So when you see cross-section, just jump. Now I sometimes used to get requests from university teachers, and well, with all my respect, they used to ask me the cross section of this. It doesn't mean anything to me. They don't understand what this means actually. So because you will see that if I could talk actually this, if I can talk, if I take this class, it will be several hours to finish with, because this is the subject that I have been working for the last 35 years since start beginning from my PhD. When my PhD assignment was given at Oak Ridge, well, I said okay, well, I will start working. And then before I work, he said that okay, you shall have to make your cross-section library. Nobody will do it. Everyone here is busy. Nobody will do it for you. So I shall have to learn it. And it was a lot of a job. Anyhow, so this technology is called nuclear data. I'm still keeping it for the our students who are coming and joining us. This is called nuclear data. Nuclear data is a subject by itself. And I will just give you an idea of evaluated nuclear data processing and nuclear reactor calculations. This is a big lecture, about 3, 4, 5 hours lecture. I cannot just, able money, or I don't, actually this is not covered in our, but cross-section is there, but it is by cross-section, as I said, in our country, we don't understand that what the technology behind these cross-sections. So when I go for a reactor design or reactor analysis or reactor safety calculations or say thermal hydraulics calculation or say the reactor design parameters, okay, what I am going to do, the design parameters, we need, most importantly, we need 2 parameters. One is the neutron multiplication factor, which is called the multiplication factor or the neutron multiplication factor, and the cross sections and the flux. Flux is the newtons per centimeter square per second. Flux is neutrons per centimeter square per second. We will define flux maybe in the future flux or something like that. We shall have to define it, flux. So the most important parameter, just remember, you can write it down, that most important parameter in the reactor is the multiplication factor, neutron multiplication factor, or simply the multiplication factor we call K. We shall have to deal with K. We'll be dealing in the whole course with K, neutron multiplication factor, and the neutron fluxes. That is the newtons per centimeter square per second. It's called neutron flux. If we know this neutron flux, actually, we can derive all other parameters, whatever they are in the nuclear reactor, all other parameters are derived from neutron flux. So what you shall have to know, you shall have to know the neutron distribution flux and their energy spectrum. And think of that, I said that, and it might have different geometry. The reactor shape can be rectangular, it can be a cylinder, or it can be any other shape. So this geometry we shall have to take into consideration. And the components of the reactor. So the cross sections for all these, and the cross sections when we talk about the why I don't understand. It gives me a warning that we're running out of time. So when we talk about the cross sections or the neutron nuclear data, we should have to remember that these cross sections, they are energy dependence, they are angular dependence, they are spectra, they are secondary particle distributions, etc. All these are required. That's why, so in cross section library files, if you see the cross section library file, you will see there are about 1,000 ID numbers, 12999 ID numbers. That means so many types of cross section. because of the angular distribution, angular spectra, and covariance matrices, and blah, blah, blah. Lots of other stuffs are there. So for us, please note that this is what we are interested to know, the multiplication factor and the flux. If we know the flux, we can derive all other particles, all other parameters that are responsible for the safety calculations, reactor core life management, reactor core management, the fuel management, in-core fuel management, and blah, 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 etc. Whatever we need, and the other safety parameters that are required. Safety parameters is the most important thing, accident analysis or whatever. So whatever you need is cross sections. And as I said, that there are about 999 ID numbers. So we shall have to get used to these, using how to use this and customize this and process this and evaluate this. And for each isotopes, how many isotopes are there? Can you imagine that how many isotopes or isotones, isomers are there in the nuclear reactor if you consider the composition of the reactor? So you can understand how vast this data technology is and why it's so important. And most of the reactor phase system, and I mean the people who do the reactor analysis or design the reactor or calculate the safety parameters, so they even don't try money. Think that how much, it's like the tip of iceberg. So in order the sufficient data, so we need, can you imagine that how many data we need? If we take a print, I will fill out this room. So these data, a very large number of experiments. What are the source of this data? By experiments or by model calculation. In some places, we cannot do experiments always because the elements are not available. Or, we can, it is energy spectra, that is energy range. In that energy range, we cannot get that to that energy range. So in that case, what we use, we do model calculations. And this is so vast that for a single country, for a single laboratory, it is not possible that they will do. Bangladesh also used to contribute very little to IAEA. So all the countries has to collaborate and cooperate to produce these huge number of data, the cross sections. To obtain the sufficient and very number of experiments must be performed. And calculations, models, development. So this is an internationally collaborated, and when you collaborate, you shall have to exchange data, right? I shall have to send my data to Oak Ridge, or Oak Ridge has to send me data to me. So this is another process. So if this is so, this amount of data is so large that it must be presented in computer readable. We cannot do it just by exchanging. It should be in computer readable format. We call it X4, EXFOR, exchange format, FOR, exchange. It's X4 is the rudimentary data, that experimental data that we produce, the model calculation data all throughout the world, all is collected by the nuclear data section. And it's called, and this is in a format that the computer can read, computer readable format, and this format is X4. So we must have experimental data and also some model calculations, and symmetries, the cross-section behavior, nuclear with similar characteristics, and similar parity in the number of neutron protons and neutron number and proton number and all these things which are being considered. When more than one measurement takes, so lots of people are doing experiment. We are doing in Dhaka, some people are doing in Oak Ridge, some people are doing in any data bank, some people are doing in Jairi, Japan, all throughout. Some people doing in even in Dhaka University. Why not the physics department? So all these experiments, can you imagine that what is the effort that is being put upon. Each must be measured. Among প্রত্যেকটা experiment, they have their error, right? All the experiments are not right. They have an error margin. And so for this, we need an evaluation. And so we need an evaluation so that an evaluation must be done to the experimental or the model calculation data that is published, the published data all over the world. The experiments that is done, all these are published. So these published data are collected by the nuclear data section. And you shall have to send it via the exchange format, that is X4. Okay. So more than one measurement. So as I said, that more than there can be hundreds of experiments. So you shall have to evaluate. Someone has to evaluate that which data is correct. So we shall have to find out the correct data. And for this, we shall have to get that the evaluation is necessary to obtain the best data, the best estimate. Which one is the best estimate? And so for this, we need an evaluation. So this is the process of evaluation. And so this data, as I said, that you can understand now, huh? You can imagine that how big the volume of the data is that. So for the use in reactor, it should be customized. First, before customization, you shall have to have a data reduction technique. All these experiments are there. You can take, so you shall have to, fix up some criteria that I will take these data. This data reduction technique is there. So for this, in view of the above, the following task associated with the nuclear data can be identified: basic nuclear data production. So if you would please allow me, I will delete this. So I hope that all of you have written it. So as I said, that in view of this huge activity that I was talking about, so the following tasks are associated with the nuclear data. Following tasks. Number one is, of course, the production. So we shall have to produce the nuclear data. We shall have to do experiment, or we shall have to do model calculation. So this will say that number one is basic nuclear data production. So, well, these are the major tasks that is associated with the nuclear data technology. How many participants are there? 30. So, do you see the screen now? Someone?
Yes, sir.
Do you see the screen?
Yes, sir.
The board, you're seeing the board? It's okay?
Sir, it's okay.
Is it okay?
Uh,
It's okay?
sir, sir, basic nuclear data, sir, I can't get it. What?
Uday Kamla too.
Basic nuclear data production, nuclear data evaluation, evaluated data processing, and nuclear data application, which actually is our part of nuclear data application. So when we design nuclear reactor systems, that is the nuclear reactor accelerator or whatever. So this is, and the flow of this information, if I write the flow of this information, I can show you that. I'm not going in depth or in details of this. Just give you an introduction and a very just a little idea about the background of this nuclear data. So basic nuclear data production. Number one is basic nuclear data production.
স্যার লাস্টেরটা তো দেখা যাচ্ছে না।
Can you see it now? Is it nuclear data application? So these are the activities that are related with the nuclear data, nuclear data, whatever we mean. And this first is the basic nuclear data production. Say data production. The first data production we do by experiment. Then theoretical calculation. Calculations. I'm just giving you an idea that how it flows, the data flow. As we shall have to use computer, and so you shall have to put it in a structure that we can use. And all this goes to literature. Literature, from the literature to databases. And there can be others also. These and these then follows to the next steps. This is one step, data production. it goes to the next step is the nuclear data evaluation. I just delete this, so the next step will be data evaluation. All these flows to the nuclear data evaluation. Who does the evaluation? Actually, these are the most experienced people in the business, in the nuclear industry. They do this evaluation that which data has to keep, which data has to be discarded. And then this evaluation, data evaluation. Evaluation, and from this we get evaluated library. Okay, I'll talk about the evaluated library, that how many evaluated libraries are in the world. We will talk about it this. And from this evaluated library, we get evaluated nuclear data processing. This is number 2 step. The number 3 step is evaluated. This comes to this box. Evaluated data processing. Data processing, and from this it flows to, actually it will be a second step here. I write it here just like in case you don't see it. So from here it to data checking. Data checking, and from this the multi-group library. Multi-group libraries, and from this application dependent, and then this to application. Okay. Application dependent library. And then number 4 step number 4 is application. Okay. Step number 4 is nuclear data application. Application, how we do, actually this will do by the neutron transport calculation. So evaluation, and from this evaluation it goes to evaluation library, evaluated library, and from the evaluated library we go to evaluated data processing. Here are, as I said, the dozens, and there are about at least 50 computer codes that are used for evaluated data processing, and then there are computer codes for data checking. And then we produce multi-group cross-section library. The cross-section library that in the evaluated library is thousands, 5,000, 6,000, 7,000 or so. But we cannot really do calculations with this. So we shall have to collapse the groups. Say I have 5,000 or 7,000 groups of data. I do the transport equation. Can I do it? Well, by nowadays with the computer power, we can do it with MCNP. But actually, the transport code, the diffusion codes, we need multi-groups, say 10 group, 20 group, 30 group, 100 group, 500 groups, and so on. So we shall have to, group it And this, you remember that the most experienced people in the world, in the industry, they do it. And we get the multi-group library. And once we get the multi-group library, then we shall have to, why we will be using this? Do we do some shielding calculation, or I do some reactor calculation, which is a thermal reactor, or I do a fast reactor calculation, or I apply it to a fusion reactor, etc., etc. So there are this application library that I was telling, that when I started my problem, first I had to make the multi-group library. I was in Oak Ridge, and they distribute the data throughout the world. But if you put a request to America, they will send it to IAEA. There is a nuclear data section in NEA data bank in Saclay, Paris. So they send it to Paris, and then there are lots of processing, bureaucracy. You shall have to go through the channels and diplomatic channels and etc., etc. After that, they will submit the codes and the data that were originated in the America. And for the NEA data bank, they supply the data in all throughout Europe, particularly Western Europe. And there is another data center in Obninsk in Russia. That is the U center, something like parallel to America. And they supply data to East European countries and the Russian Federation and Russian countries. So this application independent library that you shall have to produce. Here, finally, you are using this data for your applications, and this application it depends on what is the purpose that you will be using the basic nuclear data. And as I was telling you that this evaluated library, how many evaluated libraries are in the world? So these evaluated libraries, as I said, for Bangladesh or the third world countries, they can request the IAEA nuclear data section. You can send a request, and they will send you all these evaluated basic nuclear data library. And these data libraries, actually, you cannot do, as I said, that you cannot do anything with this, because these data are produced at 0 degree Kelvin. But our real life is not at 0 degree Kelvin. And also, you will see that we have lots of, when we study the cross section, lots of resonances, anti-resonances, and so on, lots of stuff. So for these, they are not presented in like this. They are given there as resonance parameter. So you shall have to reconstruct the resonances. And as I said, the other application, say, I shall have to use for fast reactor, then temperature have to take, you shall have to do the temperature. So there are lots of computer codes that does this. And for the, I will name a few. First, the evaluated library. What are the evaluated library in the world? This can sound something like professional, but at least you should have a background. I'm not going into details because this itself is a subject, nuclear data technology. And this is the most fundamental technology that any country should have if it has any nuclear program. So number one, say this is ENDF. I think it is B7 now. B7. ENDF, evaluated nuclear data files. B. So there is a files. A file contains all the data that after the checking that these are valid data. Then these evaluators have two libraries, data library A and library B, and only the library B is disseminated to the users. So this is ENDB, this is USA. They call it ENDF. So I started with ENDF 5, then ENDF 6, and now ENDF 7 is available, and it has version. You will see that ENDF 7 R1, R2, R3. It goes on when it becomes more, then they go to the next. Then there will be 8. Okay, so this for America, it is ENDB7. Actually, we also use ENDB7 in our library in Savar. We have ENDB7 library. And then we have the Russian library is called Brown. Brown is Russia. These are the basic nuclear data, as I tell you, that if you ask them, and they will send you this basic nuclear data in binary format. Okay, no, in BCD format. You cannot transmit binary. Binary is computer dependent. And BCD, BCD money, you can read it. Okay, so they send it to BCD. When you get a file, then the first thing is to convert it from BCD to binary. And each step you shall have to see the data. So you shall have to convert it from BCD to binary. And if you have, say, 30 computer processing code, so for the processing, so each time you shall have to process. So here the accuracy comes that here you need the supercomputer because the word length should be very high, 64 bytes. And it was very difficult at the time. Only a few laboratories in the world had this 64 word length. First computer that comes with 64 was by Sun. Okay, the Sun computers, well, I have used the Sun Advantage server in Savar also. But nowadays, this word length in the PCs was 8 bytes. So, and then it makes, I think now it is about 32 bytes or something like that. But 64 byte, you shall have to go for, the supercomputers and the big computer systems. Okay, well, that's a different technology. Okay, and this is the Brown, and the Japanese is called General. Japanese evaluated nuclear data files libraries. General, I think it is General 3 now. We work with General 2 and General 3. And they have their processing technology. This one is processed. This one is processed by a technology. This is the super technology. This is something like a superpower in the world. It's called Enjoy. Okay, I did not use Enjoy first. It was Win. It was something else. Enjoy. And the Russia have their own processing codes. I don't know what it is. And then General, they also use Enjoy. This is the most beautiful code, and I should say something like 30 computer codes are there. And I was associated with one of the computer code development, Enjoy, and also they have SRAC, S-R-A-C, SRAC. That processes nuclear computer code, the computer codes, processes the nuclear data, and also it does the transport calculation. They put it together, but it's diffusion calculation in 2 dimension. We will talk about it, the transport calculations, and this is something like 2-dimensional discrete ordinate codes called TrueTran. So they use both Enjoy and SRAC, General, and the number 4 is JEF, J-E-F, Joint European Files. I think it is JEF 2 or JEF 3, I think now. So all these European people use these JEF files, and they also use Enjoy. And also, IAEA has some processing codes. They use both the IAEA codes and Enjoy, and they have their own computer codes, and Winfrey, it started from UK. So they have their own processing code as usual as the Enjoy. Enjoy has become, one of the super. Not many countries in the world have Enjoy. Not many laboratories. Not more than 20 laboratories have Enjoy in their position. But Alhamdulillah, we have Enjoy in our laboratory. So you can process the basic nuclear data that you get from IAEA, and then customize it to your applications. Okay, this is the JEF 3 hotel, and they have General, and the Chinese have their own processing libraries. It's called Sandal, Cendel, Sandal. Okay. So these are the basic libraries. Actually, these are all evaluated basic libraries that are available. If you ask IAA, this is China. They have their own computer codes and they also use Android. Actually, everyone uses the American technology and they also uses Android and they have their own processing code. I'm not associated with this with their processing code. And IAEA has some processing codes. There it is available. If even we can get it, or any university can get this code from IAEA. So they use IAEA codes. Codes and of course Enjoy, I think, I'm sure. Well, I don't know if they have access to Enjoy. They may not have. Okay, so and now we have the fusion reactor. Now for the fusion reactor, we need a cross-section file, and that is called FANDL. Okay. This will be number 6 is FENDL, Fusion Evaluated Nuclear Data Files. It was produced in 90s, and I was a party to it actually. It was a huge job, so they gave consultancies to various people in the world, and I was fortunate to get it. Actually, I could get a job at the time, but unfortunately, our country, I was not, allowed to leave the country at the time. My boss was Dr. Emil Wajadnia. You might have known him. So he said that no, under any circumstances you cannot leave. So ultimately they said that, okay, in that case, they gave me a consultancy. And I contributed something like 18 elements to this FANDL data. And this FANDL file, it is used by CERN, it is used by the Princeton, it's used by all over the world. The Chinese people, everyone use this FANDL for the fusion evaluated nuclear data files, and you can find it from the IAEA. So IAEA is the source for us, for the developing countries. IAEA is the source that we can get this basic data. As I said, that this basic data, you cannot do anything. You shall have to customize it. And for this, you need these processing codes and the customization code. And fortunately, we have it. So actually, what I want to just finish it here, because again, I will be locked out with the time. I'm not going in details, but I will give you a print of this. This is just a small lecture on nuclear data. Maybe you can, sometimes if you go for professional level, you will find it useful. And also you will have an idea. So I just wanted to give you a background idea that how vast this technology of nuclear data processing and nuclear data. And we will definitely talk about the application, which was the live. And we have, currently we have in Bangladesh, we have NDF library, we have JEF, we have Jandal. All these are in working condition in Savar, in my laboratory. I mean, in the nuclear, what it called in the nuclear engineering, physics and engineering of nuclear reactors. In that division, we have developed, and there are the processing codes are there, and of course the neutron transport codes are there, including MCNP. So I actually say that if you have Enjoy, and if you have MCNP and PNC and MCNP, well, I was fortunate that I was in Oak Ridge, and my advisor was the director of this information. It's called RSIC, okay, at Oak Ridge, ornl.gov. You can go and see ornl.gov. There is a center called RSIC, RSICC, Radiation Shielding Information Center. So RSIC distribute these computer codes and these data. So I was fortunate, my director, my PhD advisor was the director of the center. So just by personal, we got pre-processing codes. My internet connection is unstable, so any moment I might have to shut down. So I hope that you are still with me. Do you hear me? Someone please, do you hear me?
Yes, sir.
Ji, sir.
You stop here. I hope that I tried to generate interest and also try to give you an idea of actually what is nuclear data cross-section. We will start nuclear data cross-section in the next class. And the next class, I talked with the chairman. Actually, when I called him, he